Now let's talk about how we can start getting these animations onto the character. And to do that, we're going to do what's called blend trees, animation trees, or state machines. All sorts of different software calls them different things. Honestly, they're all state machines by definition. But you're going to be really surprised at how robust these systems are. And it's because it's literally designed to be tools for the animation artists and riggers to do stuff without 100% requiring that they wait on programmers and stuff like that. It is definitely a combined effort. You have to work together and communicate really, really well. But you should never be waiting on the other person 100%. There are definitely always things you can do. You can test your own stuff in your own projects, and you shouldn't be afraid to be able to do that. So one thing we're going to do, because we're going to start creating a lot more assets, we're going to clean this up a little bit. I'm going to create a new folder called anim, and we're going to throw our animations in there. And then we'll leave these here, and we're going to create another new folder, and we're going to call this blueprints. Could be named different things, but essentially what's going to be in here is anim trees and stuff like that. So we're going to right click in here, and we're going to go to animation, and we're going to create a animation blueprint. We're going to select SK Bob. So SK Bob skeleton, because that's the one we were using. We're going to hit create, and we're going to call this ABP for animation blueprint Bob. Okay. So if we open this up, since we selected the Bob skeleton, you can see it's already got all of this data. So this is also sometimes referred to as an anim graph, but like I said, it's basically a state machine, which you can add state machines into. And if you don't know what a state machine is, just imagine when you're moving around, you're technically in states. You're either idle, or you're walking, or you're running, or you're jumping, right? You're in different states. And so that's what this does, is it allows you to control those states and say, when this state is happening, these states I made up, these are the animations that are playing, or these are the things that are happening. So the first thing that we need to do is we need to right click on the background, and we need to type state machine and create a new state machine. Now, we're just going to call this state machine like main. Some people call it locomotion. Some people call it all sorts of different things. Doesn't really matter. It is the main one that we're going to use, and we're going to left click, drag, and hold and connect it to the output pose, which whatever passes through this thing is what animation is going to be played. Now, if you try and compile and save, you're going to see it's going to say, hey, there's nothing happening. Like you have this connected, but it's empty. Because if we double left click on this, it opens up this, which now we're in that state machine. It's a new tab. It's called main. And in here, we can create different states. Now, there's actually technically, it's a little confusing at first, but there's really technically two states we need. So I'm going to right click, and I'm going to type, or I'm going to click on add state, and I'm going to call this one idle/walk/run. And it'll make a lot more sense when we get to this. The other one that we need, we're going to right click, add a state. We're going to call this one jump. Now, what we want to do is connect entry to idle, walk, and run. And you got to drag it pretty carefully, like hit this little outer edge thing. And then we're going to drag idle, walk, run to jump. And we're going to drag jump to idle, walk, run. Because basically, we are going to say, hey, whatever is happening in this state machine is being output here. So it's like this is outputting this way, even though the arrow's going the other way. I know that's a little weird, but that is how it's kind of working, because it's saying, hey, this state machine is trying to play this animation and then maybe this animation. But the thing is, you need jump as a separate one, because this one's going to be done through what's called a blend. We want to be able to blend between idle, walk, and running, not just immediately switch to idle, walk, or run. That looks really weird if you're like standing still, then all of a sudden you just start running, right? Like you can set it up that way, and you can set it up in all sorts of different ways that'll work, but this is technically what makes the most sense for beginners. And as we go through, it'll make more sense. So these little transition lines are called transitions, and their directions do matter. This means that idle, walk, and run, if the character is doing that, it can actually exit to that and jump. And when it's jumping, it can actually, it could land on the ground or whatever, and it could move into an idle walk or run, right? That is the proper way. Now, if you somehow deleted just that transition, once you jumped, you could never go back to idle walk and run. Animation wise, the game would still play how the game plays. If the programmers do it correctly, you're still going to be able to do stuff. It's just going to keep playing the jump animation. So it's important to do these things correctly. Now, what we're going to do is we're going to go into the jump state, right? And in there, we're going to drag out anim jump. Now, yours might be set on anim preview. Just go to the asset browser and it'll show all your animations. It's important that you name your animations well, or at minimum, make sure that you're using the path to kind of see what they are. Because, what if this was a jump for Bob, but you have 7 different jumps because you have different enemies and stuff like that, right? So we're going to drag in the jump. And now we're saying this is what this state does, is it plays that jump. Okay. But we need to, you'll even see if we hit compile and save, it's going to say, hey, we'll never be able to do these transitions because you don't have anything set on them. We need to connect logic to say, hey, when this happens, you can jump. So if we go into a transition, so we double click on it, we can see it has a result node that says can enter transition. It's a Boolean. It's either true or false. Like, you could technically click on it and be like, it can always enter, but that makes it pointless. You want some sort of programmatical thing that drives this. Now, to do that, up here, that is what this event graph is for. So you have 2 default nodes. This one is saying, hey, get the pawn owner, which is like the character programming wise, like the actual character that the animations are representing. Get it. Get that thing in the game engine code. Like, get it so that we can get values from it. And this one is just saying, hey, execute every single frame of the game, and we can tell it to do whatever we want. So for example, we can get what's called the movement component. So if you type movement component, you'll see it comes up. It should say get movement component. But remember that I dragged off of that, released, and then started typing, right? So we're getting the movement component, the movement code from the character, and we're saying, okay, now we have that, we can actually get what's called is falling. So this will tell us, is the character falling or not? Are they in the air? Is basically what this is doing. Now we're going to drag off of the return value, and I want you to notice something very interesting. This return value is red. This is red. That is how Unreal denotes variable types, and it's telling you that these are both Booleans. These will work together. So I'm going to drag off of it and release, and I'm going to click promote to variable. And what this does is down here in the bottom left under the blueprint settings, we have variables, and we have a new one called new var, which is what this is. Now I'm going to left click on it and then hit F2 to rename it. And I'm going to type is falling, camel case, like that. And that way I can now use this in other places. Now, right now we're telling it to do these things, but we're not executing the code. It's like we've written the code, but we haven't told the game engine to do it. That is why this thing exists. And you notice that it has the same style arrow as this. If I connect them together, then it's saying, okay, so every frame you want me to find the thing that's playing my animations, get its movement component, and find out if it's falling, and then store it in this variable. Every frame it's doing that. And since it's doing that every frame, we can right here, we can drag in is falling. We can hit get is falling and connect it. And so that way, when we're falling, we can enter this transition. Now, if you don't remember, I can click up here and I can go back to main. And you can see that the transition we were in was this one. So while we are falling, we can play the jump. When we're in the jump, we need to be able to transition out. So we're going to go into this one. We're going to drag out is falling. Only this time we're going to add one more node. We're going to drag off from its little nub, and we're going to type not Boolean. You can see it's right here. And that inverses it. So it's essentially kind of saying when we're not falling, I can enter this transition. Now, this transition is exiting, remember? So when we are falling, we can jump. When we're not falling, we leave jump and we can't go back, right? We can't go back because we're not falling yet. Only if we start falling again can we go back. That's what these transitions do. So believe it or not, you literally just wrote the programmatical code to decipher if the character that your animations are connected to is falling or not. Like, you did it. That was it. It's that simple. It's a lot of steps if you haven't done it before, and it's like a lot of different windows. But realistically, it's this. This is it. This is the whole thing, right? So there's one last thing we do need to do, though. We do need to set up idle, walk, and run. And to do that, what we're going to need is we're going to need the velocity of the character. So from this, we can type get velocity, right? Because we want the velocity, that's the speed and the direction. But we only want the speed, right? We don't want the direction also. So what that's called is the length of a vector. So if we get the vector length, we can get just the speed. That's a math thing. It's okay if you don't know that. It's something that you just learn and you have to remember. But from this, we can return off of this and we can promote to a variable and we can type for this one, speed. Now again, we need to connect this up so that it's executing every frame. And now we know every single frame what the speed of our character is. And we're going to need that here in a little bit, okay? But the other thing we're going to need is something to put here. Now, I mean, we could just be like, hey, it's idle, right? And run. But look, you can only have one. So how do we deal with that? What we need is a specialized system in Unreal that's called a blend. So we're going to right-click on our content browser, and we're going to go to animation, and you see where it says blend space. We're going to click that. We're going to make sure that we're using skbob, and we're going to type BS for blend space _ Bob. And I'm going to put another underscore and do idle, walk, run, because very often in complex characters, you'll have more than one blend space. We're going to open this up and we're at a whole new window. And this window is pretty simple at a beginner's level. Realistically, we have an x-axis and a y-axis. And what we're saying is, based on the data we're providing this, I want you to blend into different animations. Now, if you think of this from an animator's perspective, this is absurdly powerful. Because not only can this do things where it's like, oh, you're moving faster, so let's blend into a run. It can do things with directions, because it's any data you pass into it. That is how they start doing things where it's like, well, I want you to look at this character. I'm going to pass you in these coordinates, which will blend all these different animations where a character will look over to that direction and stuff like that. That gets far more complex. That's also how they do lots of different specialized animations in things like Assassin's Creed, where things interact together. Like you run past a tree and it like bumps up into the tree and he smoothly goes across it. They're blending from all sorts of different animations based on data that's passed into the system. Now, when you get to that complexity, I want you to understand 100% you're working with programmers. That is not the sole job of an animator or a rigger, but it is the job of the animator and rigger to understand what's happening, to understand these tools at a basic level, because while the programmer will pass in data to you very often, especially if it's more complex than what I've already shown you, you still need to be able to say, you know what, when my character does that thing, I don't think it looks good, so I need to adjust the animation and I need to preview it and I need to change these things and change some slight values on how it blends and all that. That is your job. Your job is to get the animations to look good. At a high complex level, the programmer's job is to say, here's the data that will drive that, here you go. But your job is to make that data work and look good. So what we're going to do is on the horizontal axis, because that's the only one we're going to use for this. This is technically a 1D blend space. We're just going to type speed And you can see it even changes it here. And the other one we're not even going to worry about. We're going to leave it at 4 divisions. Depending on how many different animations you're having, you might need more or less. But then we're just going to say, okay, well, if it's at 0 speed to 100 speed, I already know I want to change this. I want to change this to 600 as the maximum value for the speeds, because that's common, close to what Unreal uses as max speed for characters. But from 0 to 600, I want to say at 0, I'm idle. I don't want the jump. At the middle ground, so like 300, I'm walking. And at 600, I run. Now, I need to come in here and clean up these frames. I need to grab this key and say, hey, this is supposed to be speed of 0. And on the other axes, this is actually important. Put it at 50. Leave it in the middle. And then for this one, this should be at 300. And it is at 50. That's lucky. And then this one, wow, I got lucky again. It's at 50, but I want this one at 600. If these are slightly off, blends will start happening in ways that you don't expect, because it'll switch it to a 2D blend and stuff like that. So be careful about that. Make sure that it's clean. Now, the cool thing is, you see this little green X? This is the preview value. And if I hold on Control, and I'm not pressing anything on my mouse, I'm just holding on Control, I can move my mouse around and it shows you, oh, well, it's at this value. Oh, look, it starts playing that. And then it starts playing the run, and it starts playing the idle. And you see how all of them blend smoothly together, depending on the speeds. Like, they slowly start blending together. It doesn't immediately go from one to the other. Now, what's even more amazing and really cool about Unreal, especially newer versions, is in here on the horizontal axis, we have what's called blend speeds and smoothing. So the smoothing time right here, if we turn that up, like, let's say we put it at 10, which is extremely high. It even asks you, wait, what type of smoothing do you want? Watch what happens when we hold on Control. You see how there's a green X where my cursor is, but there's another one lagging behind. That's how long it's going to take the value to get there. So this is what I mean. You are the person that controls this. Like, you say, okay, you've passed in that the character is moving 600, but I feel like, based on the animations we have, it should smooth in this way, right? 10 is way too much. 1 is probably a lot better, where, you know, it's lagging behind a little bit. But if you want it to feel super snappy, you can leave it on 0. You're the artist, but these tools matter, and they matter a lot, right? So right now we'll leave it on 0. We're going to save this. And then we're going to go back to ABP Bob, which is our state machine. And remember, we're in the idle walk run state. And now what we're going to do is we're going to bring that blend space in here. We're just going to drag it in and connect it. And you see how it's looking for speed. It's looking for speed because that's what we named the horizontal axis. Well, we already created a variable called speed, so we can just connect them by dragging it in, hit get the variable, and then drag it together. And now, because the event graph is saying every frame I'm going to get the character speed, it is passing that into your blend space, and you set up the blend space, so it's going to blend between the idle, walk, and run. So for the first time, I can actually hit compile and save, and it's truly successful. Everything is set up. Now there's just one last thing we need to do, and that is connecting it to the character.